So, hello everyone, this is the first problem of today's Div 2. And in this problem, we are given that chef has an array A of length n, and he wants to make a permutation using this array. Now, we need to find whether there exists an array B consisting of n non-negative integers such that the array C constructed as Ci is equals to AI plus Bi is a permutation. Now, I hope everybody knows what a permutation is. So let's look at this here. So we are given that we have an array A of size n, and we need to find whether there exists another array Ci such that Ci is Ai plus Bi. This array B can be anything, any like array of non-negative integers, any array of non-negative integers. So you just need to find whether they like for this array A, there exists a array B such that Ai plus Bi, this new array C can be a permutation. Is the problem statement clear? So if this much is clear, then let's say that let's look at array A. So if we sort it in increasing order, so let's look at here. Like if we are adding non-negative integers to every index at every place, we cannot like decrease any value because we can add anything from 0 to infinite. So we can only increase. So finally, after sorting A, let's say I want finally this thing 1, 2, 3, 4, 5, 6. So how much do I need to add to this? Nothing. How much do I need to add to this? 1. How much do I need to add to this? Nothing. How much do I need to add to this? Nothing. How much do I need to add to this? So here, if even if I am at 0, this will still be more than this, and I cannot add -1. So for the first time, if I find this, my answer will be no. So if I find this even once, then my answer is no. Otherwise, if this would have been something like 4, then I would have simply added 1, and here I would have added nothing. So this was my array B, this is my array A, and this would have been my array C. So then my answer would have been yes. Is this clear? Yes, no. Okay, so let's go to I'll quickly show you the solution. So this is the implementation. In this, I have first taken array A as input. This is my check. If f is 1, my answer is yes, otherwise no. Then I'm iterating through my array and I'm just checking if at any place ai is more than I plus 1. Why I plus 1? Because I'm starting from, like my indexes are start from 0. So if at any point my value is more than the final value which is needed at this, like after sorting, the fifth value should be not more than 5 because I cannot add a negative integer. So that's the only condition. If it is, then I'm marking my f as 0. If f is 0, I'll print no. So is the implementation clear? Okay, so let's go to the next problem. Okay, so this is the second problem, and in this problem, we are given that there are n boxes of candies and n boxes of chocolates. Now, we need to distribute these, like we'll choose exactly one candy box and one chocolate box, and we'll distribute these among m students. Now, every student should get exact number of chocolates and candy. Like individually, they can get any number of chocolates and any number of candies, but the total number of sweets received by every child should be same, like the total of candies and chocolates. So we need to count the number of ways to choose one box of candy and one box of chocolate, so that every student is getting equal number of sweets. So let me explain this here. So we have n a1, a2, all the way up till an candies, and we have n chocolates, b1, b2, all the way up till b. Now I can choose any ith candy and candy box and jth chocolate box. So ai plus bj is the total number of candies. Now this should be divisible by m. Why? This should be divisible by j. This shouldn't have any remainder. Why? So that I can equally divide this number. This is the total number of sweets, right? I need to exactly divide this among all students or among all children. So just like how to do this, see, if ai plus bi is exactly divisible, ai plus bj is exactly divisible by m, that is this thing. This would simply mean, let's say, if ai is having some divisor, ai modulo m is something, and bj modulo something is this y. So what will this give you? Simply x plus y should be divisible by m. Then only this is true. ai plus bj is then only divisible by m if the remainder of both of these is divisible by m. So simply what we can do, we can just make a map of for every, like how much is the remainder of every value of b under m. So let's create a map. Why? Because then I'll iterate through these values, and due to this condition, I know that if ai is having x under modulo m, then I'm looking for values which are m minus x. M minus x should be the modulo of values which are in B. Those can be paired with ai or at the ith place. So I'll add those to answer. Is it clear? Yes, no? If anyone is having any doubt, you can ask me. Otherwise, I'll move to the implementation. Okay, so let's look at the implementation. If you're getting wrong result, probably like you have some implementation mistake. So in this, I have taken, like, first of all, don't take int. Your answer should be in long long. That's one thing which can cause your wrong answer. So in this, I have taken, first of all, array A, and for that, I'm having this map. Like for every value, what is the modulo under M? Then I'm iterating through second array, and whatever is the modulo under that, I'm also calculating whatever the values are having, like modulo under M. Then finally, I can go from 0 to n, and I can add how many times in M2 I am getting this much as my modulo. What is this? M minus V1 of I. V1 of I was what? Why to map? Because you can use array also, by the way, not map. Because What is the biggest value of key in M1 and M2? It is M minus 1. Nobody will have modulo more than that. And what is M? Just I need to check what M is. If M is in range, M is less than this. So you can use instead of array, like instead of map, you can use array also. If that makes more sense to you. Is it clear? So basically what we are doing here, how many times this value, V1 modulo, I don't think I have to, I'm not using M1, right? So I don't have to calculate this. So just like I said, if for one, for B, I'll calculate how many times I'm getting the values under modulo M. And the second is just iterate through the first, and that is array A. Whatever the current modulo is, this is the current modulo of array A value. I'm subtracting it from M and I'm checking how many times that value is appearing as modulo in array B and adding that to the answer. So anyone having any doubt in this? Okay, so let's go to the next problem. So in the next problem, we're given that the goodness of a permutation is the maximum integer k such that the permutation can be split into exactly k subarrays for which each subarray has same sum. Now you are given an integer n and we need to generate now we are given an integer n and now we need to generate a permutation of length n such that it has the maximum goodness. And if multiple such permutations exist, then if multiple such permutations exist, then with the maximum goodness, then we can print any. So a permutation of length n consists of all integers from 1 to n in any order. So this is the definition of permutation, and this is how we split. So let me explain this. So a permutation, let's say this is the permutation. So let's say these are the subarrays which have equal sum. So there are 4 subarrays. So 4 is the goodness. So we need to find one such permutation which has maximum goodness, like which we can divide into maximum number of subarrays with equal sum. Now, what is the total sum of a permutation? Sum of permutation is nothing but I will go from 1 to n summation I. This is nothing but, I have told this many times, that this is n into n plus 1 by 2. So this is the sum, right? Yes, no? Now, let's say you have k subarrays and each subarray is having some sum as alpha. So this is n into n plus 1 by 2, right? Total sum. There are k subarrays, each subarray is having alpha as a sum. This subarray is having alpha, this is alpha, this is alpha, and the last one is also alpha. So 4 times alpha is total sum. Now tell me one thing, what is the minimum value of alpha? The minimum of value of alpha is at least n. Why? Because n will be in one of the subarrays, and whatever subarray is having n, that subarray sum will be at least n. So alpha minimum value of the sum that you can choose is n. Now, alpha is minimum n. K times alpha was equals to constant, that is n into n plus 1 by 2. Now, clearly, you can see if you increase alpha, your k will decrease. And what is your k? K is your goodness. Alpha is the sum of subarrays, the sum of each subarray. So you shouldn't increase alpha. Why? Because your k will decrease. So let's try to take alpha as n. If you take alpha as n, your k will be n plus 1 by 2. So you can have these many subarrays. This is your goodness. But there are two things. N is odd, n is even. If n is even, then k will be like the subarray will be some decimal. So you cannot have decimal number of subarrays. You cannot have 3.5 subarrays. So that's why in this case, k is equals to n plus 1 by 2 is not possible. But in this case, let's look. If alpha is n, k will be n plus 1 by 2. So is it possible to have this? Yes, it's always possible. How? We can have always n plus 1 by 2 as n will be one subarray. Every subarray will have n sum. Next subarray will have 1 and n minus 1. So this is one subarray. This is one subarray. Next will be 2 and n minus 2. So like this, we'll have exactly n plus 1 by 2 subarrays. Each will have n as the sum. In this case, we cannot have n plus 1 by 2. So what is the next thing? Instead of having alpha as n, we'll have alpha as n plus 1. So if you place in this equation alpha as n plus 1, you'll get k as anyone? N by 2. And it turns out this is also possible. Like we'll have, instead of having alpha as n, we have alpha as n plus 1. So we'll pair up 1 and n, 1, 2 and n minus 1. So this is your new permutation, 3 and n minus 2. Every subarray of size 2 is having sum as n plus 1. Is it clear? And you'll have n by 2 such subarrays. Is it clear? For n equals to 2, how many alpha should be n plus 1, which is every subarray should have sum as 3 and k is n by 2. You'll have exactly one goodness, exactly one subarray. So 1, 2, 1 goodness, sum is 3. So let's look at the implementation. 1, 2, 2, 1, does it matter? So this is the implementation. For even, the thing is you can have not like the best thing was you can have n plus 1 by 2 subarrays. But for even n plus 1 by 2 is odd. So you cannot have that. You cannot have half subarray. So that's why let's have the next best thing. Let's say that our subarray sum will be n plus 1. So in that case, your number of subarrays turns out to be n by 2. And how to achieve this? Pair 1 with n, 2 with n minus 1, 3 with n minus 2. This way, each of the two elements, each of the two length subarrays will be having sum as n plus 1. There will be exactly n by 2 subarrays, half. Is it clear? Okay. So this is the implementation for, first of all, for even, I'm just pairing I with n minus I plus 1. So 1 is paired with n minus 1. 2 is paired with n minus 1 is paired with n. 2 is paired with n minus 1. So if you look at n minus I plus 1, that is exactly what you'll get. 1 is paired with n minus 1. 1 is paired with n. 2 is paired with n minus 1. 3 is paired with n minus 2. So that every subarray, two length subarray like this gets the sum as n plus 1. In case of odd, I'm just pairing I with n minus I. So 1 is paired with n minus 1. 2 is paired with n minus 2. Every subarray this way will get sum as n, and what is left at the last is printed at the last, n. So every subarray is having sum as n. From here, this part I'll get n by 2 subarrays, and from this part I'll get one more subarray, that is just n. So n plus 1 by 2 is the number of subarrays that I'll get, or the goodness for this odd length permutation. This is just end line, new line. Is it clear? So let's go to the next problem. So in this problem, we are given that we have a tree consisting of n vertices where each vertex u is assigned a value au, and you start with a score 0 and perform the following operations as many times as you like. Pick a vertex u whose current degree is odd, add au to your current score, current, remove this vertex u and all its incident edges from the graph. Find the maximum score that you can. So let me explain this. Don't worry about submissions. Like, don't try to judge your skill on the number of submissions. Like, you don't know how half of the people made those submissions. So don't worry about that. So in this, we're given a tree like this. And by the way, it's like this is a easy problem only. Like, this is not that hard. So like this, and each time we can choose a degree, a node, or a vertex which is having odd degree or odd number of edges connected to it. We can delete it, add the score, whatever was corresponding to this, to our answer, the value to our score corresponding to this node, and remove this node and all the incident edges also. So this is the tree. The tree is broken. Finally, after we have done this, we need to finally tell what is the maximum score that we can get. Is the problem statement clear? Like in this case, I can further delete this. So I'll be left with this. Then I can delete any of these. This is also having degree 1. This is also having degree 1. Is it clear what we are required to do? Now tell me one thing. Is it any way possible to delete all the vertices ever? Is it possible to delete every vertex? No. You cannot delete all the vertices since you are deleting vertices one by one. So there will be a point when there is just one vertex left, and that will have degree as 0. So if degree is 0, it is not odd, you cannot delete it. So there will at least be one vertex left. Yes, no? Now this turns out that you can always have just one vertex at the end. Why? Because if you are given a tree has a special property that for any tree that is having nodes more than 1 or more than equals to 2, it turns out there will always be a leaf node. If you root your tree at one point, there will always be a leaf node. And if there is a leaf node, the leaf node will always have degree as 1. So you can always delete that node. So you'll always delete root nodes one by one until just the root is left. Is it making sense? Yes, no? Only the root will be left, you cannot delete it. But other than that, you can delete all the leaf nodes one by one. Now, the only thing left in this problem is how to decide this root. Now, you'll get every vertex's value added in your score, but you won't get roots value added to your score. So by greedy logic or by like just observation, your root should be the node with the lowest value. Is it making sense? Because you are not deleting this. You're not adding the value to for this node to your score. So how will you solve this problem? You can just find the node which is having the lowest value. Say that this is your root node. Start DFS from here. Mark every vertex, like just keep on deleting the root leaf level nodes. That is your final answer. Any doubts? Okay, so let me show you the implementation. You can use priority queue, but that's not actually required. I'll show you why. You can just iterate through your graph. Once you are done with a vertex and you're going back to its parent node, what does that mean? It means that you have iterated through the complete child nodes of that or complete subtree of that node, right? So that is what I've done. I have first taken and the values for every node, array A. Then I have created a graph. Then this is the minimum value in array A. So by default, minimum gives me a pointer. So this is the minimum value, and I have marked my root as whatever is the value at minimum point, like the node which is having minimum value. So that is my root. This is the number of nodes that can be deleted. I have started my DFS from root node, and while iterating, at first I just keep going downwards. Once I have gone completely down and I'm returning back, that means I have completely iterated through all the subtree level nodes. So while returning, I can check this thing. If the current node is not equals to the root node, I can print that node. Why u plus 1? Because I start from root is starting from 0. So this is the implementation. Any doubts in this? Yes, I'll draw a graph and explain it. So let's take a test case such as so let's say this is the graph. So you'll start from, let's say you first find that this is the node with the lowest value, least value. So what you'll do, you'll start from DFS, you'll go down, and when you're going back, you'll print this node. This is the leaf node. So this is your node that is printed. Then you'll go down, and when you're going back up, you'll print this also. Why? Because this is the leaf node. Then from this node, you'll go back up. Now from this node, if you're going back up, you'll print this also. Why? Because now this is the leaf node. Both of these are removed. Then you'll go down. Once you're going up, you'll print this. Same for this, same for this. Go down, go back up. Once you're going back up, print this node. So finally, once you come here, you won't print, once you're returning from this node's DFS, you won't print this because this is the root node. So this is what is done in the implementation. If you look here, is it clear or any doubts? Okay, it's clear. Let's go to the next problem. Why no, root node is not printed? Because you cannot remove every node. And n nodes can. Once the only root node is left, it is having degree 0. No edge is connected to it. So degree 0 is not odd. That's why you cannot remove it. So one node will always be left out. Is it clear now? Deepak. Yes, we run a DFS because order matters. So now we'll go to the next problem. So in this problem, we are given a string S consisting of lowercase English letters. Count the number of ways to break this string S into 3 strings P, Q, R such that P plus Q plus R is equals to S. Concatenating P and Q, that is P plus Q is equals to P plus R, not P plus Q. Concatenating P plus R gives us Q. P plus Q, R is Q. So we need to count how many number of ways there exist like this. So let me explain this. So we are given a string S. Now we need to break this into P, Q, P, R, Q, I think it was. P, R, Q. such that P plus Q plus R, or we have PQR, right? PQR is equals to S, and P plus Q is equals to R. Is this thing right also? P plus R is Q. P plus R is Q. So this is P, Q, and R. Like this thing. Q is big and R here. I have written it correctly, right? P plus Q plus R is S. P plus Q plus R is S. P plus R is Q. P plus R is Q. So now let's just replace P plus R with Q. P plus R, this thing is Q. So 2 times Q is, if we just look at the length, P plus R, like this can be written as P, like P, the length of P plus the length of Q plus the length of R is equals to length of S. Similarly, P, length of P plus length of R is equals to length of Q. So if I replace these with here, I'll get P plus R. Length of P plus length of R is length of Q, plus length of Q is equals to length of S. So 2 times length of Q is equals to length of S. So what is the length of Q? Length of Q is length of S by 2. Right? Now, what if N is odd? If N is odd, that is the length of S is odd, then answer doesn't exist. Because then in that case, your length of Q should be odd, which is not possible. Like length of Q should be decimal, like in decimal. That is 3.5. You cannot have 3.5, 4.5 as the length. Now, if the length of, for odd, we already know in case S is odd, solution doesn't exist. If S is even, how to find this? So let's look at this. If S is even, we already know that Q is exactly S by 2. So what we will do, we'll have length of Q is equals to length of S by 2. So basically this is our string S. Length of Q 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So length of Q is exactly half. So either we can have string Q as this, that is the first 5 characters, or the next 5 characters, or the next 5 characters. These, or these, or this, and finally last 5 characters. So if you are checking the first or the second 5 characters, how to check? Basically, in this case, this character should be the prefix of this. These 4 should be the suffix. Is it making sense? Or in a better way, just iterate through your string. Like first, if you're here, if you're looking at this substring, then this would mean these 2 should be prefix of string, these 3 should be suffix. Is it making sense? If this is true, then your answer is, then you can add this to your number of ways. So now there are many ways. You can have string hashing. You can have KMP. You can have Z algorithm, KMP. There are many ways. I have done this using Z algorithm. This is, if you have the template, this is also very easy. You can just use string hashing. So let me explain. Like this much is clear, right? This is the only solution. After that, this is just implementation. Okay, so let me show you the implementation. So this is the Z function. I won't like, since this is like Z function is like sorting. If you know, like there's no point, like if you're discussing problem, there's no point to discuss how sorting is actually happening, right? So that is Z function. If you are aware of this, it's okay. If you're not aware of this, like either I'll share some resources, or the best is like try to solve this the way you know. Like if you are anyway, if you due to this problem you learn something new, that is the algorithm, it's best. But otherwise this problem is solvable using hashing also. So if you know hashing, you can try out with hashing also. The logic will remain same. First of all, if n is odd, the answer doesn't exist. Otherwise, for Z algorithm, due to Z algorithm, I have first like created a temporary string t, stored string s in it, and reversed t, so that I have string s and reverse of it. Then in both of these, I have this Z function calculated. Then finally, because Z functions will only work like they are prefix matching, not suffix. So that's why t is being used. So then I'm iterating through every substring of size n by 2 that is starting at 0 and will go up till n by 2, like the starting point. And I'm checking this is how this is matched. That the number of characters that are matching is at sz1 is more than sz, more than or equals to sz1. Why? Because the length of prefix which is matching up till now is more than these. Like I said, the starting two characters should be. I'm checking that the starting two characters, these things are matching here. But it is also possible that these three, like instead of matching just these two, like this was my substring, right? Instead of matching these two with these two, I have that these three are matching these three. So in that case also, it's okay for me, because as long as these two are matching, it's okay. And same thing is being checked here, that any like if these more than three characters are matching with last these characters, then I'm good to go. So that is what is being done in string matching using Z algorithm. So if this is more than sz1, if this is more than sz2, then I'm increasing my answer, that I have one more possible way. Finally, I can print my answer. This is the same way you'll do this using string hashing also. So any doubts? Okay, if not, we can stop. So that's it. Thanks for joining.